My dear students of CE806, Structural Analysis and Design of Concrete Structures 2 Sessional. This is lesson 4. Breeze part lesson 4. And in the previous case, we had lesson 3 and we had a discussion class on lesson 3 also. By this time you know this all these influence lines there. In the lesson 3 we have dealt with influence lines for shear force, live load shear force. We have dealt with influence lines, and using those influence lines now we will be calculating the actual value of shear, live load shear. In live load shear there are two types. One is the wheel load. One is the wheel load portion, another one is the distributed load portion, and we are dealing now with the wheel load shear separately, and we will be dealing with the distributed load shear next. And now as you see the page, wheel load shear, and in wheel load shear, in the influence line, you see there are two parts. One is a positive part. One triangle is a positive one. The other triangle is negative one. These two triangles are similar. This is point 1, location 1 at the center of the brace, at the suspended span middle part, and the ordinate at this influence line is 0.5, and the wheel loads are, as you know, wheel loads are 58.1, 58.1 and 14.5. We have put these values in this in the previous diagram, and we have just shown the values in this space. The small wheel, after multiplying with the other factors, is 14.5. The big wheels are 58.1 and 58.1. In the influence line, we have shown this position of these wheels. Now we will, from the geometry of that is influence line, we will calculate the actual values, numerical values. Here B1 and B1 plus or minus, the numerical values will be same. As you see, the diagram is similar. One is a positive one, another one is negative one. That's why we will calculate one and that plus minus. And here at the middle of the span at location 1, the influence line coordinate is 0.5 and the wheel load is 58. That's why we have multiplied it 58.5 into 5. After 14 feet, another wheel will be coming up after 14 feet, and the third wheel will be coming up there at 28 feet apart from the main or the central wheel. That's why the next wheel will be multiplied by, the wheel load is 58.1 and the distance from center to the position of that wheel load is 30 minus 14, and the ratio will be 30 minus 14 divided by 30, and the ordinate at the original position at the center is 0.5. That's why for finding out the ordinate, that this 14 feet distance from the center, we have to do this arithmetic, and we will get the value for the second big wheel, larger wheel, and the smallest wheel is 14.5, and the distance from the center of the influence line diagram, the position of that wheel is up at a distance of 28 feet from the center, and that's why the ordinate will be dependent on 30 minus 28 by 30. We have to multiply the value 14.5 wheel load by this fraction, and we have now shown the detailed calculation here. We have ultimately put the sum total of this value. The value is 45, keep plus and minus, because the plus triangle and the minus triangle is similar, and this is V1 plus and minus. And in V2 there is no minus. This V2 is plus everything is plus V2. At the beginning of this V2 triangle, the ordinate is 1, keep or keep. That's why the 58 kip, the bigger wheel will be at this one, the left location, and the ordinate of that moment, the shear diagram influence line is 1 kip per kip. For 1 kip, there will be 1 kip shear. That's why we have kept it 58.1 into 1 is 58. Next wheel will be after 14 feet, and that will be 60 minus 14 divided by 60. That will be the ratio for that wheel, 58.8. And the last wheel will be at 28 feet from the original position of the triangle, and that is 60 minus 28 by 60 will be the ratio, and 40. The third wheel will be the smaller wheel, 14.5, and that sum total will give us a value of 110.4. That goes B2. And in position B3, there will be a right side. At the right of this B3, there will be there are two shear diagrams for B3 at right and at left. At right, the shear diagram is a triangle, and then first of all a triangle and then a rectangle. But as the distance is 30 feet, the wheels will be within this triangular part, and that's why the 58 and 14.5, all these will be multiplied by 1, 1 and 1, and total is here comes as 130.7. The negative value, for negative value, we have to go for the triangle on the bottom side of this previous lecture. The triangle at the bottom side of this previous figure, that is in previous lesson, the position is such that the bigger wheel will be at the bigger triangle with the ordinate of 1 kip per kip. There this will be 1 kip per kip. The triangle is such that this, if you put a load 1 kip at the left of the support of 3, the shear will be there 1, and if we put the wheel load at 6, the shear will be 0. That's why this triangle is a 90 feet long triangle, and the loads are naturally are 58 and 14.5 like that. Then for this value, we have to first of all multiply the 58.1 by 3. By 1, and another 58.1 will be multiplied by a factor where the triangle is has a 90 feet base, and the wheel is at a 14 distance from the maximum ordinate. That's why we have to reduce from 90 minus 14, that multiplied by 1, and that is the ratio for that position, wheel load action. And the next one will be calculated after deducting this 28 from 90, and that divided by 90, and multiplied by the load ordinate of load value of 14.5. And this way we have just found out the value for L 3 left. We have found out this value of 3 at 3 left, and this putting all these value, we have got this 3 right and left as 3 right is there as I have written. Yes, this is 130.7 and 3 left is 117.2. And if we go to the next page of the previous lesson, page 4, then we will get the other values, shear at position 4, 5 and 6. Position 4, 5 and 6. Position 4, 5 and 6. in the position 4, the positive shear is very small. As you see the triangle, this triangle, the length of the triangle is only 30 feet, and of course the wheel load will be there. When the wheel load will be there at the right hand side of this point 4, then the ordinate of this triangle is maximum ordinate of this triangle is 0.33, and the negative triangle ordinate is 0.67. That's why in this position the negative shear with a maximum value of 0.67 at the triangular diagram is more than this smaller one. Definitely, by observation we can see that the smaller triangle will give you smaller values and bigger triangle will give you the bigger values. And there are some similarity in these figures. You see the left shear of 4 and right hand shear of 5 is similar and same, and in this way we can just find out by seeing the similarity we can find out some of the values and pick up from the previous calculation, and like that we have just shown that plus 5 is equal to minus 4 and minus 5 is equal to plus 4 and plus 6 is equal to plus 3 left and minus 6 is equal to 4. All these value I put in the bottom of this figure, that wheel load shear. We have calculated the values or shown the values V1, V2, V3, V4, V5 and V6 like that, and just from these triangles and from the ratios where the wheels will be set 14 feet every 14 feet, we can find out all these values and get the live load shear for the wheel load only. In this influence lines there is another factor, that is distributed load, that is 1.04 kip per feet, and we will be calculating the value for this 1.04 kip per feet separately in this next page. Distributed load shear, factored distributed load, as we have shown that this 1.75 is the ultimate load factor, 9.33 by 10 is the beam spacing factor, and 640 is the main allowable distributed load, and we have divided that by 1000 to make it in kip, because we have so far dealt all forces, all reactions, etc. in kip, and multiplying these 2-3 factors we have got a value of 1.04 kip per feet. I have shown this 1.04 kip per feet in the figure all through work. That means we will be putting these values wherever we will get the positive value with the value with the similar sign. We will be adding this distributed load for shear and moment, where this distributed load gives positive, and if the original load is positive, shear load is wheel load is positive, then we will add this together, wheel load. And the distributed load shear for V1 plus V2 is V1 is equal to If you go back to page 3 of the previous lesson, then you will be finding out that how distributed load has come here. Distributed load in this V1 position plus minus is same, and the nature is same. That's why the numerical value will be same, and that's why we have calculated one value, and maximum ordinate is 0.5, and distance is 30, and this is a triangle, that's why we have to have half base into altitude. This half is 0.5 and load per running foot is 1.04, and that the arithmetic calculation gives us a value of 7.8 plus minus. In V2, at the maximum point the ordinate is 1 kip per kip and the distance is 60, that's why point, and this is a triangle, that's why the average of this 1 and 0 is 0.5, distance is 60, the peak point of this influence line is 1, and the distributed load value is 1.04, and after calculating this we get 31.5. And for the next one we have to, this is 3 right and 3 left, 3 right and 3 left is 3 right and 3 right is for distributed load, 3 right is 1 multiplied by 1.404 into 30 distance, and the other one is the triangular one, that gives us a value of 62.4, and three left is 0.5, 3 left is 0.5 into 1.045, the distance is 90 feet, and another is 0.5 is the distance is 90 feet, 3 left, plus 0.5 average of the triangle is triangle, as this is the load is a triangular one. First of all we have put this half base into altitude, then half is half, and 0.33 is the ordinate, and load is 1.04 and the distance is 90, and this also gives us a value of 62.4. And next, if we go to the next page of the previous lesson, we will go to for minus, plus 4 and minus 4. Plus 4, as you see, this triangle is a very smaller one. Normally we do not calculate this value, because this just by observation it is seen that the value is so small it can be easily neglected. But we have put here the value and calculated the value, and we have found is 5.1. And in the similar way, if we calculate the other values just by putting this 1.04 load up to the distance where it will affect the section with positive or negative form of forces, we have gone through this and calculated these values up to V6. And at the V6, the maximum value is 47. At V5 the maximum value is 21, I'm sorry. At V4 the maximum value is 36.3, and V3 the maximum value is 62.4 and 62.4, and V1 is 7.4 plus 31.2. Distributed load is here. And first of all we have calculated the dead load shear. As you know, in the previous lesson 2 or like that, you will see that there are values for shear at different points, so selected points there are values, shear values for dead load. And here in the previous lesson we have calculated and shown the shear values for wheel load, and now we have calculated the values for distributed load, and now we will combine all these three together to get the final design shear value, shear chart. And on next page we have shown these locations are 1 2 3 4 5 6, 3 left and right, and this is shear chart. Dead load shear, we have to bring it from the previous lessons, and we have brought those values here and listed here this shear values. For 1 is 1.8 and for 6 it is 71.9. Everything is in keep. Everything is in keep. Wheel load shear, we have to find out the maximum wheel load shear, and we have put this wheel load shear in the second line, the wheel load shear column, and put this from the wheel load shear calculation from the previous pages, and distributed load shear from the previous pages. And after all these with plus minus etc. sign, and we have just added these values plus 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 plus, where this plus all will be coming up as added values, and in shear we will have only one form of shear, that is either it will be the maximum one will be either positive or negative, and we will be designing the sections or the shear stirrups or shear section and shear reinforcement for the maximum numerical values. Those will be coming up in this list, in this table, and there is nothing to be explained here. We have to find out the previous two or three charts, that is dead load shear chart, wheel load shear chart, and distributed load shear chart, and you will see the plus minus signs and bring it here, and after adding plus with plus, plus with plus, and minus with minus, we will see which one is bigger, the plus one or the minus one. Then we will use for the stirrup design and shear section design, we will be using the maximum numerical values for the shear consideration. We will take the maximum numerical values for shear, either it is positive or negative. In moment you will be seeing that if there is positive and negative moment in a particular section, we have to provide top and bottom bars, but in shear we don't have left and right bars. We will be using the maximum numerical values for calculating the shear spacing. Thank you very much for this.